The James Webb Space Telescope has unearthed evidence that could point to signs of human-like activity far from Earth, bringing humanity closer to answering the timeless question of whether we are alone in the universe. The search for extraterrestrial life has been a constant thread woven through the history of human civilization, inspiring countless literary works, philosophical debates, scientific theories, and dreams. Our fascination with understanding our place in the universe and the possibility of not being alone seems almost ingrained in our nature, driving us to seek companionship, even if that companionship might come from an extraterrestrial origin. With each passing decade, we inch closer to uncovering the answers we've longed for. But as we edge toward them, we must also confront a deeper, more unsettling question. Are these answers truly what we seek? Or is there something even more profound driving our relentless curiosity? In 2021, the James Webb Space Telescope team posed a hypothetical yet groundbreaking question about the future capabilities of space observatories. Could our telescope detect artificial light on another planet, such as Proxima Centauri b? This nearby exoplanet, the closest known to Earth, orbits within the habitable zone of our nearest stellar neighbor, Proxima Centauri, situated roughly 4.25 light-years away. Astronomers believe that Proxima b was tidally locked, much like our moon is to Earth, with one side perpetually facing its star. This led to the intriguing possibility that a technological civilization living on Proxima b could transfer energy and heat from the planet's day side to its dark night side using advanced technologies, perhaps through photovoltaic cells that generate electricity from sunlight. In fact, a published study with Manusvi Lingam among its authors explored this idea, suggesting that significant coverage of the day side with solar panels could potentially be detected by future telescopes. With the James Webb Space Telescope representing one of the most advanced pieces of astronomical equipment ever built, its increased sensitivity and broad range of observational capabilities in 2024 have opened the door to the tantalizing possibility of detecting artificial light sources on distant habitable exoplanets, such as Proxima b. If the James Webb Space Telescope has indeed found the light we've been searching for, this could propel humanity into a transformative new chapter of its cosmic story, one that redefines our understanding of life, intelligence, and our evolutionary trajectory. But before we leap to the implications of such a discovery, it's crucial to understand how this achievement was even possible. The James Webb Space Telescope's mission has brought the mysteries of Proxima Centauri b under sharp investigation. Throughout the span of human history, we have sought answers to some of the most fundamental questions. What is the nature of the universe? Why do we exist? What is our destiny? These profound and seemingly unanswerable questions have driven human curiosity for as long as we have been able to contemplate our own existence. In this modern era of exponentially advancing technology, the question naturally arises: are we any closer to finding these answers? A philosopher might argue that despite all our progress, we are still in the early stages of comprehending the cosmos and ourselves. Yet an astronomer, gazing into the vast depths of space through the lenses of powerful observatories, would be thrilled to share the latest discoveries about the universe, confident that each technological advance represents another step forward in humanity's evolutionary march. While many of these advances slip by unnoticed by the broader public, they stand as historic milestones that reshape our understanding of reality. Now, with a world of data literally at our fingertips and instruments like the James Webb Space Telescope at our disposal, it is time to push forward and explore the universe in ways we never could have imagined before. One of the most exciting frontiers of this exploration is the search for life beyond Earth. The James Webb Space Telescope, as the heir to the long and storied legacy of human space exploration, has been designed to help answer some of the deepest questions we have about our place in the cosmos. It has already begun to shed new light on the possibility of life existing beyond our solar system, as evidenced by the recent potential discovery of signs of life or artificial activity on Proxima b, a planet located light-years away. Proxima Centauri b, or simply Proxima b, is classified as a super-Earth exoplanet orbiting an M-type star. These super-Earths are planets that are more massive than Earth, but significantly lighter than the gas and ice giants like Neptune or Uranus. This makes them a unique and intriguing class of objects in the universe. While much remains to be uncovered about Proxima B's composition, atmosphere, and potential for life, the possibility of detecting signs of activity or artificial light on its surface marks a significant leap forward in our ongoing quest to understand our place in the cosmos. The idea of planets orbiting other stars has fascinated humans for centuries, and the first possible evidence of an exoplanet dates back as far as 1917, though at the time it drew little attention or recognition from the scientific community. It wasn't until 1992 that the first confirmed detection of an exoplanet sent shockwaves through the astronomical world. Since then, the field has exploded with discovery after discovery, adding more depth and complexity to our understanding of planetary systems beyond our own. By April 1, 2024, a staggering 5,653 exoplanets had been confirmed in 4,461 planetary systems, of which at least 196 featured multiple planets. These remarkable discoveries are mostly associated with M-type stars, also known as red dwarfs. Red dwarfs are the smallest stars in the main sequence and are far more common in the Milky Way than other types of stars. However, due to their low luminosity, observing them poses a challenge, requiring highly sensitive instruments like the James Webb Space Telescope. Red dwarfs are classified and named based on their temperature and size, often referred to as M dwarfs. These stars, with surface temperatures hovering around 3,900 Kelvin, have particular characteristics that set them apart, characteristics that make planets like Proxima B all the more fascinating. Proxima B is estimated to have a mass roughly 1.07 times that of Earth, and it completes an orbit around its host star in just 11.2 days, a stark contrast to Earth's 365.25-day orbit around the Sun. This rapid orbit suggests a small, dim host star, and indeed, Proxima Centauri's luminosity is astonishingly low. Across the electromagnetic spectrum, it emits only about 0.16% of the Sun's luminosity. In visible light, the figure drops even further to about 0.056%. Over 85% of the energy it radiates comes in the form of infrared radiation. Proxima B orbits at a distance of about 0.04856 astronomical units from its star, a proximity that, despite the star's dimness, places the planet within the habitable zone where liquid water could potentially exist. The discovery of Proxima B was first announced in 2016, but why has this particular exoplanet attracted so much attention from astronomers and space agencies worldwide? One reason is its sheer proximity. Proxima B orbits the closest star to our own Sun at just over 4.2 light-years away. Though this distance seems unfathomably vast to humans, it is considered relatively close on a cosmic scale, making Proxima B a prime candidate for the search for habitable worlds. Proxima B is part of the Alpha Centauri triple star system, and despite its host star's faintness, it has remained an object of great fascination for astronomers and planetary scientists alike. The Proxima Centauri system shines prominently in the night sky, ranking behind only a few other notable constellations such as Sirius and Procyon. However, the most intriguing aspect of Proxima Centauri B is its position within its star's habitable zone, the so-called Goldilocks zone, where the conditions might be just right for life as we know it to arise and persist. The possibilities suggested by this arrangement are truly limitless, and astronomers have embarked on a new era of exploration to probe the depths of this stellar potential. This is precisely where the James Webb Space Telescope enters the scene. The telescope's four main scientific goals include searching for light from the first stars and galaxies that formed after the Big Bang, studying the formation and evolution of galaxies, understanding the formation of stars and planetary systems, and investigating planetary systems and the origins of life. As the JWST continues its investigation of exoplanets like Proxima B, we move closer than ever to achieving these goals. One of the most compelling aspects of space exploration today is the search for extraterrestrial life, not just microbial life, but potentially intelligent, technological civilizations. This quest has inspired projects like the Search for Extraterrestrial Intelligence, SETI, which stems from humanity's innate curiosity and determination to explore not only what moves, but also what does not move, scanning the cosmos for any sign, any whisper, any signal that might point to intelligent life beyond Earth. SETI imagines the universe as a kind of cosmic treasure hunt, where instead of seeking gold or precious resources, we are searching for electromagnetic signals, subtle, deliberate, or accidental transmissions that could reveal the existence of civilizations far beyond our wildest dreams. As the James Webb Space Telescope gazes deeper into the cosmos, examining the faintest of signals and the dimmest of lights, humanity stands on the precipice of discovery, waiting to find out if we are indeed alone in this vast, mysterious universe, or if the universe holds secrets that will forever transform our understanding of life, intelligence, and our place among the stars. Even as the James Webb Space Telescope, JWST, tirelessly surveys the skies, the vastness of the cosmos continually offers new surprises that challenge and expand our understanding of what it means to be human. With its remarkable technological abilities, JWST has brought us face to face with the possibility that the universe might hold signs of intelligent life far beyond Earth. For centuries, humans have gazed at the stars, weaving stories, myths, and scientific theories about beings who might exist somewhere out there. This fascination is not merely a passing curiosity, but a profound reflection of our longing for connection, our need to situate ourselves within a broader cosmic context. It's as if we are searching not just for others, but for deeper truths about ourselves. In 2021, when scientists posed the hypothetical question of whether a telescope like JWST could detect artificial light on distant exoplanets, few imagined how quickly this idea would shift from theory to tantalizing possibility. They looked specifically at Proxima b, the rocky exoplanet orbiting Proxima Centauri, our nearest neighboring star system only about 4.25 light-years away. Proxima b has been a point of fascination ever since its discovery because it lies in a habitable zone, the region where liquid water could potentially exist on the surface. The idea was raised that if a technological civilization existed on Proxima b, they might harness solar energy from the sunlit side of the planet to illuminate or warm the perpetual night side, much like how humans distribute energy across continents. Researchers like Manusvi Lingam proposed that vast networks of solar panels covering the planet's day side could produce detectable signatures, subtle but discernible through the right combination of infrared and optical observations. With the deployment of JWST, we gain the sensitivity and spectral range to examine this hypothesis more seriously. Designed to study faint infrared signals across vast cosmic distances, the telescope became an ideal tool to search for energy anomalies or spectral irregularities that couldn't be explained by natural planetary processes. As the telescope pointed its golden honeycomb mirrors toward Proxima Centauri, scientists held their breath. Would the data reveal anything unusual? And if it did, what would it mean for humanity to recognize the distant glow of artificial light, an echo of civilization flickering from across interstellar space? The significance of such a discovery cannot be overstated. Throughout human history, the search for extraterrestrial life has been driven by equal parts scientific inquiry and philosophical wonder. From ancient myths of celestial gods to the sophisticated radio searches of the modern SETI, search for extraterrestrial intelligence, era, we have always projected our hopes, fears, and curiosities outward, asking, are we alone? Could other intelligent beings be looking back at us asking the same question? The JWST's capabilities have thrust us closer than ever to potentially answering that question, not through speculative fiction,